Welcome back to the Automate Construction Podcast. We're joined today by Fastbrick Robotics CEO Mike Pivac out of Australia. Welcome to the podcast, Mike.
Thanks, Jared. Great to be here.
Yeah, you guys have been doing construction automation, the first public company CEO crazy enough to be on the Automate Construction Podcast, and I really appreciate that. Eager to talk about the extended story of construction automation versus a lot of the 3D printed construction CEOs I talked to. Some are brand new or just a few years old. Really excited to get your perspective today.
Thanks, Jared. Great to be here.
Yeah, so I wanted to talk about some of your new partnerships and your extended experience in using robotics on construction sites, some of the laser-guided tools you have. But first, I want to just ask, what made you realize that blocks should be placed with robots instead of people?
Look, that part of the story goes back over 15 years, actually, where we had a bricklayer shortage in Australia, which occurs cyclically as the building activity goes up. The availability of bricklayers remains the same, so everybody's fighting for the same labour resource. And back in 2005, this hit another critical point where the cost of laying a brick in Australia doubled in a 6-month period. So some seed funding was gathered up amongst 2 or 3 parties, and the first $3 million was applied to designing and putting together the very first Hadrian prototype. And that was completed around about 2007, 2008, but then along came the global financial crisis, and of course all funding for projects like ours dried up. And I wasn't involved with the project back then. It was simply my cousin Mark, who's the Chief Technical Officer of FBR now. He was working on his own with another team, and it wasn't until 2012-ish that he and I got together and decided to bootstrap the company ourselves and push forward, because it had come around again where this demand on bricklayers in Australia had hit a peak point, and the cost of laying a brick in Australia had more than doubled again. And what we found back then, and it's the same now, is that every day there are less bricklayers or masons in the world than there were yesterday. So they're retiring at quite an alarming rate. The average age of a bricklayer around the world is now over 50 years of age. There are around about 2 to 3, somewhere between 2 and 3 trillion bricks and blocks laid around the world every year. So you don't have to be Einstein to work out that if there's a problem of that magnitude and potentially you have a solution to it, as those two things converge together, potentially you have a very good value proposition to attack. And that's what we've done. So when Mark and I really put our heads together and our bank accounts together back in sort of 2012, what we wanted to do was to take that very initial prototype that Mark had developed and demonstrate it actually working. Now that took us a couple of years to make that happen, but we were able to demonstrate it building a very small structure. And of course, we had some investors around looking at what we were doing, and we simply said, look, if we can put 10 bricks down in the right spot, we can put 1,000. If we can put 1,000, put 1,000,000. If you can put 1,000,000, you can put 1,000,000,000. And from there, we had an opportunity, given that the venture capital network in Australia was basically non-existent back in 2012. Mm-hmm. We had an opportunity to reverse list the company and list it on the ASX, and raise our first $6 million to get the project up and running properly. But to answer your very initial question, we have a very unique technology that Mark developed, almost 20 years ago for a completely different industry and application. But what he found at the time was that the market for that tech wasn't as big as what he would like. But when the opportunity came along to apply it to a machine that could lay a brick or build a house from one position with a very long and stabilised boom system, you bring all those things together with that continual demand that's happening around us all the time. It made perfect sense to, head off down this pathway. Now we're 8 years into the journey as a public company. We're at the point now where we are at the commercialisation phase. So we've done a lot of machine development. We're in the 3rd iteration of the machine now. We've had our 2nd iteration of the machine working in Australia for the last few years. We kicked that off about 4 months after COVID hit. We took the opportunity to go out and build our very first house for a real customer in Australia during COVID. And since then, we've built a whole range of things with that, what we call the 109 prototype. And now we've developed the 110 machine, which we believe is the commercial machine. And we're about to demonstrate that to the world in a much more significant way.
So before you did the public listing, did you have adhesive being applied to the blocks? Was that already involved in the original prototype?
Look, there's some very early footage getting around of Mark playing with wet mortar and bricks and robots, and it's a messy undertaking, I can tell you. And this was a very interesting sort of point in our journey, because construction adhesive has been used in Europe for over 15 years, and some of the very largest materials manufacturers have developed products to enable bricks and blocks to be laid in the very cold winter months where wet mortars generally freeze. So it was a European development, and they made this stuff in like a foaming form. And we looked at that and thought, well, gee, if we're going to move away from wet mortar, this is a very, very big sort of decision we have to make. So we did that. We went to a liquid form as opposed to a foam forming adhesive. And we started building structures on our test slabs and in our lab using adhesives. And then we started to bring various industry participants in to see what we were doing to gauge their response. And honestly, 100% of the response was, at last, somebody's doing this. Because most brick and block manufacturers have developed an accurate block system with a thin bed mortar requirement. But the uptake from the bricklayers was very, very minimal, if at all. In most cases, it was zero. The bricklayers were simply saying, look, we need the mortar joint because that's our levelling agent. That's what we use. We put a bed down, we plonk a brick on it, we tap it into place, and we put a level on it, and we make sure it's where it needs to be, and then we lay the next brick. Whereas for us, with a machine that builds from a CAD model, using an accurate brick and putting it on a pretty good slab, you can eliminate the need for a mortar joint. And one of the really distinct advantages you get, Jared, is that you don't have any requirement to let the structure dry before you can continue to build up vertically. So in most cases, you can only build 2 or 3 courses with a wet mortar before you have to let that stuff dry off before you sort of continue your way up the wall. Whereas we have no limitation on how high we can build vertically in a day. In fact, we now build whole house structures in a day without having to stop and wait for anything to dry. So it's a very important part of our machine and system. We didn't pioneer the use of adhesive in construction. That was done by the Europeans. We've just adopted it for our robotics system, and the two things have come together beautifully.
Very cool. What's the tallest building that you've constructed with the system so far, Adrian?
We have our machine on site today, and the walls that we're building out there are 9.4 metres in height. So it's 2-storey. It's a 2-storey structure. Our new machine can build to 4 stories. And yeah, we can sort of get, depending on how close you want to get to the machine, we could go higher than that. But if you want to build a full 4-storey structure from the road edge, you need a machine that's got a 32-metre boom, a 100-foot boom, which is what we have. And you need the ability to be able to deliver product over that distance and lay it with accuracy. Now, the laying of a block at 100 feet with accuracy in all weather conditions, day or night, with all your different wind loads and your releasing of load and weight at that distance, introduces its own amount of boom movement and inertias, and you've got to account for that in real time. So the core to our technology is what we call DST, or dynamic stabilisation technology. And what we do, Jared, is we read the interference at the end of the boom 1,000 times a second, and we correct for that movement 1,000 times a second, and it allows us to place a 30-kilo block of masonry 100 feet away with millimetre accuracy, regardless of what the boom's doing. So that's the key to our tech, and it's why we are the only people in the world doing it with a fully mobile, highway-capable machine that can arrive on a building site, set up within an hour, and lay blocks at 300 blocks per hour and potentially build a whole house structure in one working day. And
is it that same system that allows the machine to recalibrate when you move it to a new location?
Yeah, sure. You can leave today with a half-built structure and arrive back on site tomorrow and pick up exactly where you left off and just continue building. In fact, some of the structures that we've built have been like multifaceted in terms of the way they're designed. So we'll build the first section or phase of the building, and we'll go away for a month and come back and then rejoin and add another part of the structure or another 2 or 3 units to that structure, go away, come back when the next slabs have been laid, and rejoin it all together. So yeah, we don't need things to be sort of like separate in design. It can be one big structure like a school or a commercial centre, and we could have 3 or 4 machines operating on the same site, all running off the same CAD model and working in collaboration with one another. Now, we haven't demonstrated that yet because we haven't got enough machines, but that is the true capability of what we've developed. And when you bring that into markets where there are a lot of low-rise commercial, there's a lot of low-rise commercial activity going on, particularly with precast and tilt panel and all that other stuff. If you can bring multiple machines onto a building site, you can do potentially what takes 2 months, you can do in 2 weeks with a number of machines. So
I'm sure you'll test that multi-machine collaboration a couple times before you let me come out there with the camera. But
yeah,
I'm super
absolutely.
curious, what was the original industry that your CTO was trying to apply the technology to?
Well, he had a history. Well, Mark's an aerospace engineer, mechatronics engineer, and a mathematician. Are his 3, sort of core skills.
Incredible.
Yeah, but he's also an avid windsurfer and sailor. And
Nice.
what he wanted to be able to do was design, the world's largest sort of CNC machine, if you like, to be able to mill out boat molds very quickly from one position. So like, 30 metre boat hulls, being able to machine out the fiberglass molds for that particular industry. That was where his mind went early when he realised that he could stabilise a boom at that distance to that level of accuracy. It's important to note that even 10 years ago, when we first started really working together properly, computer processing speed wasn't quite there where we needed it to be, and nor was the laser technology that we use in amongst our system. Neither of those things were truly where we wanted them to be, but we knew that within 2 or 3 years they would be. So we've continued to develop and progress the machine on the basis that as technology is developing and improving in front of us, we're sort of slurping up that improvement as we go and introducing it straight away into our tech. So that's the approach we've taken. That was the industry that it was first designed for. But along comes a big construction problem, and we had a solution on the ground that we thought we could pivot really quickly to this, and that's exactly what happened.
Yeah, that's a great answer. Interesting to see how something developed for one industry can apply to something else. And you bring up a really interesting point about your philosophies and the benefits of contributing to construction automation, even in the very early stages. Since you have that digitalization, you have the as-built models, when these new technologies are coming out, you're able to add them on, bolt them onto the machine, and
Yes.
take advantage of everything, like the mountain you've already climbed.
Very quickly, yes. And we're always looking at that mountain in front of us. And as any sort of technology pioneer will tell you that you think the mountain that you're climbing is the last one, but when you get to the top, you realise there's another one that you've got to get over. So it's a continual journey. But as long as you're making progress and you can see that you're getting closer to sort of the technology adoption level you've got to get to before the industry will take you on. It's one thing to come up with a technology for an industry, it's another thing for them to adopt it and take it on, okay? And that there's a lot of work that goes on there in terms of socialising a new tech, getting your industry participants to understand the positive and negative impacts that that's going to have to their business, to their industry. It also allows them to understand potential new verticals and new ways of generating revenue, and that's happening with us now. Because when you think about it, for brick and block manufacturers, they make a product, they put it in the yard, they wait for someone to buy it, they deliver it to a building site, and then that's it. And then someone else comes along, they find labour, they eventually put the structure up, and away the building goes. Now, for us, the way that we're attacking this problem in the industry is to partner with brick and block manufacturers. We see them as a natural partner because not only do they get to ensure that bricks and blocks remain a mainstay product in the building industry, but now potentially they pick up a large proportion of the laying revenue that they currently don't get. So it's an attractive thing for brick and block manufacturers from that perspective, and it's attractive for the builders because they can maintain the speed of output that they need. And this is another thing, and you and I have already spoken about this before, but getting your technology into the industry can be a very difficult thing if you're not showing improvements in the areas that they want to see. And in construction, it's all about speed. Time is money in construction. Just chisel that in stone, okay? If you can save a construction company time, you are saving them money. So you've got to be faster, at least equal to in speed. You can't be slower. And then, of course, you've got to have other add-on value for them as well. And I think FBR presents that very, very well.
Yeah, and so the system, let's try to demystify it a little bit. When somebody's having an FBR home built, is there anything you need to tell the slab contractors doing the formwork, foundation, and maybe electrical plumbing in anticipation of the Hadrian coming on site?
Electrical and plumbing, no. What we do with our slab team or teams is we ask them to give us a certain tolerance over a certain distance, so like 3 millimetres over a 5 metre distance, which is very achievable. But if you look at the way we do slabs in Australia versus the US versus Europe, so in Europe, for instance, they rough in slabs. They really rough them in because then they put the underfloor heating, all the wiring gets sort of secured to that roughed in slab, and at the end they put a self-levelling screed over the whole lot. That's a European method. In Australia, we produce generally reasonably low quality slabs because that's all the industry wants, because the bricklayer then comes along and he'll just add a bit more cement here or there, a bit more mortar to the brick and sort of level things up as best as he can. But what happens with that as a method is that you find that from earthworks right through to completion, every single contractor that comes to site has to do remedial work on the contractor that was on the site beforehand. So there's like, fix it up first, then do your job, then move on. The next guy comes along and goes, right, I need to fix that bit up first so I can do my job, and then I can move on. What we've found and demonstrated very well is if you start with a good quality slab and then you put good quality walls, the benefits of that flow all the way through to the end of the construction process. Okay, so starting with a good datum point is always a good way to approach something, whether it be in construction or any other industry or anything that you're doing. Start with a good foundation and you find that you get benefits flowed right through. And we're demonstrating that to our customers now.
That seems like a very logical place to start. So then you place the laser reflectors?
Yeah, we simply have these little reflectors that we put on the corners of a slab, on the sort of like on the slab face. 2 or 3 of those is ideal. We take a survey of that slab. That way we understand where that slab is in 3D space. Okay? That enables us to come back to that slab at any time we want in the future, realign to the slab very quickly and start building again. And sometimes we just leave those reflectors on and drive away because they're a very cheap little thing that we put on, or we will remove them and reuse them. But that's a very simple part of our process, is understanding where the slab is in space.
And that gives you that key stabilization feature that wasn't available 10 years ago and you got today.
Yeah, so once you know where that slab is, and you know that it's got a certain level of tolerance to it, laying bricks on top of it is the easy part. Okay, the key bit, as I've already mentioned, is being able to stabilise the placement of that product over such broad distances, day or night, most weather conditions. And when you put down a 20 or a 30 kilo piece of material at that distance, you get automatic boom movement just comes in, and you can't stop and wait for that boom movement to steady out and go away before you lay your next brick. You've got to be laying your next brick while all that movement's still happening. Okay, so there's a lot of, I suppose, technical brilliance in that part of our machine and system, and it's very unique to FBR. We are the only people that place product over that distance, and we are the only people in the world that have developed a fully mobile, highway-capable construction robot. That said, the similar technology can be used in other industries to place product. It doesn't have to be in the construction industry. It could be in the maritime industry, for instance, where you have a lot of ship movement and other things where you require stabilisation. They've already got some methods that they're using for certain applications, which is great. We see some things that potentially we could apply the technology to in the future. But the issues that we see in construction, I think, are going to keep us busy and probably our grandchildren busy, Jarrett. I think we haven't seen a lot of change in the construction industry for decades, really. I mean, there's a lot of, sort of smaller type tooling has come in to make things, better, cheaper and faster. Handheld tools, nail guns, all those things have come in. But in terms of, big, clunky mechanical machines, the last time anything like this came into the industry was really the concrete pumping truck. And that's 50 years now. And back in the early days of that, if you study the history of concrete pumping trucks, the adoption rate was quite low and slow. But now, you don't see people putting concrete in a wheelbarrow and moving it 6 feet. You put the conch straight into a concrete pumping truck and you move it 6 feet. So that whole industry's just moved to that. It's like, we don't use humans for that anymore. We just use trucks and vehicles. We know what they cost. We factor it into the process. We know it's going to arrive at this time and it's going to depart at this time, and it allows the builders to stay on schedule. And that's a really critical part. You can't disrupt a builder's schedule, because the moment you add time, you're costing them money. So hence the reason why we think that our approach to fully mobile construction robotics is the way to go. And we are very, very heavily focused on delivering the customer what they want, not delivering them something that we have and we'd like them to change to. So we're fitting in with them. That's our key bit. We're working very hard to fit in with industry. We don't want them to have to change or adapt to us.
I imagine anyone with plans to build a CMU house out of cinder blocks, like the system you have in America designed to work with cinder blocks, would be able to apply that plan and have it built with your technology?
100%. Yeah, whether it's a house or a school or a strip mall or whatever it is. Mm-hmm. And we've got design and patent protection over high-rise systems that are very similar to what we have on a vehicle, where it gets delivered to site, has jack-up legs, and you feed it very similarly the way that we feed the Hadrian 110 now, and a shuttle system delivers the blocks to the lay head, and that can be as high as you want. You can go to 30 stories with a system like that. So
and what's the difference between the typical block and a block that would go through an FBR system?
What is different?
Yeah.
We just put the block, goes through a rectifier. The last part of the process as it comes out the plant is we rectify so we get a nice level top on the block. And then it just gets either wrapped, strapped or palletized and then delivered straight to the machine. So there's only one more very, very low cost process that happens to the block. It's basically a block as you'd see out of any block plant, and it is a block that you see out of any block plant. It's just had a rectifier pass over it before we palletize it.
What's the process for a plant to add that rectifier to their system and be able to produce your block?
We're actually going through that process with a manufacturer in the US at the moment. It's only $200,000 to add that component to the plant, and of course you get 20 odd years of use out of that.
Nice.
They have wear parts and other bits and pieces, but it adds around about 10 to 15 cents to the cost of a cinder block. Okay, but we pick that cost up in the speed with which we deliver it into the wall. So there's no additional cost to the builder. We absorb that and into the lay cost, if you like.
Yeah, and so then that block gets delivered on site, and how does it get loaded into the Hadrian?
We use a standard telehandler that you'd see in any sort of yard, construction yard, or on most construction sites. And we just fork them into the back of the machine. The machine can hold up to 4 pallets of blocks in the back of the machine. And the de-hacking robots They understand which blocks are where. We obviously have a vision system in the back, so you can have what we call the skinnies, the internal wall blocks can be in the back of the machine. You can also have the larger external wall blocks in the machine at the same time, and the de-hacking robots will pick the right block at the right moment and deliver it in the right sequence to the layhead. That's standard automation. Yeah.
So when you say internal and external block, is that for Australian construction standard and the US standard is all the same block, or is that incorrect?
No, even in the US, the internal masonry block is half the width of an external masonry block. Okay, but you don't see a lot of it in the US because predominantly the timber framers come in after the external wall's been built by the masonry team, and then they build the internal walls out with timber frame stud wall. But we compete very strongly with that, as you can imagine, because while we're there doing the external walls, we can print the internal walls at the same time. And for us, it's a very important, revenue component to our business plan, because if you're only doing the external walls of a standard 4-bedroom house in Florida, that might be somewhere between $15,000 and $20,000 worth of work. If you leave them, you're potentially leaving $10,000 to $12,000 worth of internal wall work for the timber framers. Whereas we want to build complete masonry structures, internal and external. You can imagine the uplift in terms of building strength if you do that, okay? So there's benefits there, but there's a big benefit to the builder in that you can basically eliminate another trade coming into that site. So you don't have to go, external walls, wait for your framers, internal walls, then roof and onwards. You get the whole structure, then it's roof and then it's onwards. So we're eliminating one trade and therefore picking up some time for the builder.
Yeah, and you also have full customization of the size in between the inner and outer layers so you control the R value.
Correct, yes. And the construction adhesive that we use, it's really important that we sort of talk about this a little bit, because it's a very, very strong material, and it's already in your homes. It's in the desk that you're leaning against, it's in the chair that you're sitting on, it's in probably the walls behind you. Similarly, in where I'm sitting at the moment, this is a material that's been used in construction for many years. We've just had it certified for masonry to masonry, and from that, and use the European method instead of foaming material, we've converted it to a liquid material because it's easier to handle. We don't have any waste. We don't have to worry about wind blowing foam around a building site. And we can turn our adhesive system on and off with the flick of a switch. But the strength that we get out of that material is quite extraordinary. So it's about 3.5 times the strength of standard wet mortar, and it's about 1/5 the cost, okay? And like I said before, it allows us to build with no vertical limitation. We can just keep building upwards. Every 45 minutes, that material is completely set. And we can engineer and adjust the set time of that material to suit the build if we want to. But generally 45 to 60 minutes is a good set time, because it means by the time you come around for your next course, the bricks underneath are fully set. What you get at the end of the build then is you get a structure that is much stronger than traditional build method, to the point where we believe that, and we're yet to demonstrate this, but we're pretty confident that we should be able to eliminate the need to have some of the cement grout that goes down into the wall cavities. We should be able to remove some of that and maybe even use less steel in the structure too, simply because of the strength we get out of the adhesive. So it's an important factor in the way that we're approaching this, and sort of socialising the new system with the engineering community in the United States. With your regulatory bodies like the ICC and Florida State and now Miami-Dade as well. And all these people are doing their own testing. You goes through the full gambit of testing procedures, whether it be, shear strength testing, ballistics testing, all those things happen before anyone will give you, the tick of approval. And we've had that done 3 times now, and we're doing it again. And every state that we move to, we'll probably have to do it again. And every country we move to, we'll have to do it again. But that's fine. We're sort of well attuned to that now.
Sometimes some states will fall in lines with the others if you get the tricky ones like California, New Jersey.
Yeah. Well, Miami-Dade's important, Jarrett, because if, Miami-Dade has the I suppose the biggest challenges in terms of
Hurricanes.
construction, the strength of structures in that region because of the high wind loads that they get. And we see, Miami-Dade certification as the Mount Everest of certifications, if you like. And if you can sort of point to that and say, well, look, we've got it here, so we think we'll be okay there. It doesn't give you an automatic tick in the box, but it certainly helps the conversation.
Yeah, I guess they have some of the most challenging conditions, but it's not the most respected certification in terms of there have been a couple collapses in Miami over the years.
Mm.
But I'm sure most of the places you're building are stringent, and I'm sure Miami is stringent too. It's just so challenging with the porous land and the salt and the rebar and stuff like that.
Yeah.
Um, so the adhesive, do other contractors use that without the FBR system, or they are so dependent on it for leveling they're afraid to switch over?
For manual masons and bricklayers, they want that waterbed for the levelling purpose. As I said, most brick manufacturers over the years have produced a quick brick system, so like a brick that's been through a rectifier, like the bricks that we use now, and they mix up a very fine tile grout type adhesive, and they brush it on the brick and then sit the next brick on top. But the uptake on that has been low to zero over the years because that's not how bricklayers learn their trade. That's not what masons do. But for us, it was ideal because we've taken what the brick and block manufacturers sort of pioneered themselves many years ago, and now we've come up with an automated system that can utilise that technology that they've basically sort of worked on themselves. So while humans don't want to use it, it's ideal for machine.
Very cool. And you're expanding into the U.S. with a system designed for U.S. block. We talked about a little bit. I know there's some details that'll have to be left to a future episode regarding that, but what can we talk about there?
Well, as you pointed out before, I think in your introduction, I'm one of the few or only public company CEOs that you've spoken to, and it's well, there's two reasons. There's not many of us in the construction automation space. Most are privates and VC backed, whereas we're not. And that's obviously a well-trodden path, and there are hundreds of companies around the world undertaking their progress and plans based on that type of a funding model. For us, it's different, and the big difference for me is what I can talk about in the public domain, because obviously I can't give you any information today that the market doesn't already have. And I can't discuss anything with you that would, sort of influence anybody buying or selling a share in FBR. That said, the benefit of being a public company CEO is I can promote on platforms like this with you. And being a public company, anybody can invest in us. You don't have to be invited to come along as an investor to get in behind one of these things that you might like as a technology. You can invest in FBR today via your broker if you want to. So that's the benefit of it. But we are restricted as CEOs. We are restricted about what we can talk about and when. But I'll be happy to come back on your show when we do release some more information and give you a bit more background to it, Jarrett.
Unfortunately, not my broker. I'm not a sophisticated investor, so Robinhood needs to get better international support, I think.
Yeah, well, you don't need to be a sophisticated investor to buy shares on the ASX. You just need a broker to handle the transaction. So mums and dads can we're very heavily regulated, as you can imagine, as a listed company in Australia. You're independently audited, and the ASX is very heavily regulated and regulates us very heavily, which is to protect your mum and dad investors at the end of the day. So it's all
So we'll wait for the story about what's going to happen in the United States. But for now, let's get back to the construction process. So we're talking about the adhesive. You have the bricks loaded onto the Hadrian system. They go down the conveyor belt.
Yep.
It matches up with the lasers to confirm the calibration, and the bricks get the layer of adhesive on them and then stacked on top of each other. There's a person holding a tablet the whole time.
Yeah, there's two ways of operating the machine. One is walking around the site with a handheld tablet or HMI controller, human machine interface control system, like you see with the people that operate concrete pumping trucks and other types of machinery. They have a handheld controller with them, but you don't want to be standing outside on a building site all day if you've got a machine doing the work. So we also have a workstation inside the cab of the vehicle, and the telehandler operator's sitting in a air-conditioned, climate-controlled cab of the telehandler. And there's no human hand interaction requirement on the build, like no human hand touches a brick in our system. The only thing we do once every 30 minutes or so is we do a walk around, and if any brick requires any sort of slight manual intervention, it might need a tap with a rubber mallet here or there, potentially. But given that we build, non-cosmetic load-bearing structures, everything that we build is going to have another material applied to it, whether it be a stucco material or a cosmetic facial material like another face brick or a panel type material on the outside. So we don't have to worry about the cosmetic appearance of the structure as much, but we do still take pride in what we build. So when we deliver a structure to a customer, we want that to be the best it possibly can be. But yeah, the manipulation of the machine is either tablet or in-cab control.
And then someone checks the placements, and are any other trades on the job while the printer's running?
No, not at all. There's generally not even any people wandering around the work site. It's just simply a slab. And
Sorry, not a printer.
well, it is a printer.
Okay,
We
great.
don't use that term often because the 3D concrete printing companies, really pump the fact that, pardon the pun, that they are, printing structures. But we're a 3D printer too. The difference is instead of using, wet mortar materials, we're using a QC'd product straight out of a factory, the way it's used today. But the system, it's still 3D printing a structure, Jarrett.
Certainly additive manufacturing. I remember one of the older models also had some maybe subtractive manufacturing. There were routes pre-cut into some of the cinder blocks in one of the renderings for electrical and stuff to go flush in the wall.
Yeah, so one of the things we always dreamed of doing, and we still, can and probably will, is put a router in the machine as well. So that, when we get the CAD model from the builder, generally we know where every tap, every light switch, where every electrical conduit will run through the walls. So it's very simple for us to actually bore the hole in that block where it needs to be, so that when the electrical contractors do come along, it's simply a drop down through the cavity, and all your MEPs come down through the cavities because they all align. You don't have any wet mortar dried inside those cavities obstructing the cavities. So all of your cavities are clean and open. So all of your MEPs can come down through the wall cavities now. And yes, we always said to our industry participants and partners that the next phase of this is we'll bore the holes where you want them as well, and that should take another sort of contractor out of the building process as well.
So for now, before that step, when the printer leaves the site, the Hadrian X leaves the site, you have all of the cinder block walls up, plumb square, and at this point, do you need to tell anybody else that it was built with a Hadrian X system?
No, we don't. We just sold another house that we built yesterday. We bought a string of land lots, about 2 years ago during COVID, because we wanted to ensure that when we wanted our machines to go out onto real sites for real builders, that we actually had land underneath ourselves. So we just sold off another one of our houses just yesterday. But the room you're sitting in right now, do you know what the walls are made of behind you?
The facade is brick. It's probably stick built. It's an apartment, two-story apartment building.
But you don't know, really, do you? I mean, you could
No, I
turn around
don't.
you could turn around and tap the wall right now and probably get an understanding of it. But as long as it meets code requirement and as long as it passes engineering, there's no need for anyone to know whether it was built by hand or built by robot. But some people do. Some people are really quite interested in having.
Sorry, I meant still in the construction process. So like you have the walls up, the electricians, the plumbers, the roofers, the window fitters, the door guys. Do they just treat it like a cinder block product? Do they need to know that it was built with a Hadrian system?
Well, with your door frames, we bring them down from the top, okay? So we don't brick into the door frames like a traditional mason would do. So the guys that are coming in to do that last bit of work, in fact, it's usually our team that does that anyway. So when we leave, the lintels are in, the door frames have been dropped in place, and the next load of bricks have been laid, or next course have been laid over the top of the door frames. The next person that comes along after us is the people that fit the roof trusses. Now there is a little bit of communication goes on prior to the build, because we say to the roofies, okay, this is going to be built with a robot, so you'll need to use this particular type of roof tie. And that's pretty well the end of the conversation. From there, the trusses get tied to the walls, and then the stucco goes on and the roof lining goes on, and then once the windows and doors are in, it's a lock-up stage.
Why does the roof tile matter?
It doesn't. It just means that once it's sealed on the top, your internal work can start to happen on the building. And that's a really important phase to get to in the build process, is lock-up stage. Okay, because as soon as you've got the roof on and your doors and windows in, your internal contractors can start their work. But until that roof goes on, you can't, because there's so much different materials need to go on the inside of the house that can't be exposed to the weather. So the house has got to be sealed up before a lot of that stuff can happen. And one of the things that we do is we get the builder to that process faster.
Very cool. So I guess now we have the whole house built. Somebody goes in, does the kitchen, the appliances. Besides the details about the door, which I guess you guys handle yourselves, most of it, pretty much all of it, is the same as traditional CMU. So
Yeah.
you have how many human operators on site once they're trained up?
2 to 3. I like 3. We can do it with 2, but if you're doing it with 2, you've got to take into account lunch breaks and bathroom breaks and those sorts of things. Whereas if you've got 3, you can always have one on a lunch break or a bathroom break or something, and you don't have to stop the machine, which is really important. So having that extra human there, even though it's an important point to make, the humans that we have on the site are still the most expensive part of what we do. Okay, even though we have quite an expensive robot building the house structure, it's the cost of the humans that is still the largest component of our daily charge, or our daily cost, I should say.
And how's the primary responsibility split? Like a tablet holder and the person who's loading the system and tapping the blocks?
Yeah, we have a machine operator. We have what we call a person in zone, or a PIS guy, who also loads the machine. And then we have a general hand, okay? And your general hand can be doing, anything. He can be whizzing off down the road to get another truckload of blocks and bringing them up to the machine, or he can be
picking up coffee.
He can do all that. Yeah, he can also be doing any manual manipulation with any bricks, if sort of doing a walk around. But we generally find that our general hands and our PIS guys are trained up on the loading of the machine. And often one of our PIS guys is also a stand-in operator for when the operator needs to go for his lunch or his bathroom break. So we cross-train the guys. But three's
Nice.
ideal. Three's ideal.
What's the onboarding period for someone to be trained?
Well, look, I think we've done, in the last year, we've probably trained, a dozen or so people up to operator level. I think I'm right in saying that number. It doesn't take long to learn the system, but I think getting confidence in using a machine like this takes, a couple of months. So we sort of take, a few months, like a 3-month approach to this. We bring a person on and say, okay, we're going to train you up to be a machine operator. And within a couple of months, they can actually work the machine, but they're not confident to be doing it on their own for at least a few months. Some people are, some are really gung-ho. They're like, yeah, no, I'm good to go, rah, and in they go. Others are like, yeah, I know what I'm doing, but I'd still like to have someone next to me for a little while longer. Just depends on the individual. I think as time goes by, with this new machine of ours is much easier to operate than the previous machine. Obviously, we've made a lot of improvements on the operability of the machine to make it simpler and make it easier to train. Okay, so if you've got well, I can tell you what it's like in Australia. It's very difficult for construction, labour, regulatory bodies to get young people to come into construction as a career choice, okay? And particularly laying bricks and blocks, it's not a 21st century career choice for school leavers, okay? Now, there's a couple of things going on locally in Perth. Like we have a construction training centre in Perth, Western Australia, that's funded by industry, that allows schools to bring their teenagers along and introduce them to what a crane operator might do, or what an excavator operator might do, and they get to play with certain bits of equipment to try and encourage them to take construction seriously, and potentially as a career choice. Now, it's a damn hard thing to do, and they don't have a lot of success, but they do the best they can. It's just simply that young kids spend so much time, doing this with their thumbs and in front of screens. Trying to get them to use a trowel and a wheelbarrow and a spirit level is almost impossible. So we think we've hit that nice middle ground where we can still say to a young person, construction's cool, and so is the equipment that's coming, and here's a good version of it. Get into this and drive this very large construction robot using a hand controller without having to lift heavy things or put themselves in dangerous situations. I think it's a perfect outcome for the industry in terms of encouraging school leavers to take construction on as a career choice. I think we fit quite nicely in there.
Yeah, that sounds incredible. They'll be the perfect job force to operate that type of equipment.
Yeah,
And they
right.
want to pursue computer jobs, engineering jobs, working with robots, technology. At least that resonates a lot with me. I think that a lot of people believe that too, but maybe I'm just projecting on them.
Well, look, when I was a young man many years ago, on weekends I would earn extra money by pouring house slabs with a wheelbarrow with a team of 6 or 8 other blokes, other guys, and that was a way that we'd earn extra money on a Saturday or a Sunday. Was to that didn't use concrete pumping trucks. 40 years ago in Western Australia, you used human beings, and you didn't really. Well, you weren't cognizant of the safety risks that were apparent and around you. All right, you were ignorant to it. Now you even grab a school leaver or a teenager that's in high school and take them to a building site, a normal human-built building site, and they probably won't walk onto it because they'll see all these hazards. Particularly now that they see silica dust in the air, if there's bricks being cut using a handsaw and all those sorts of things. The on-site safety that construction, I should say the lack of on-site safety the industry has had to deal with over the last number of decades has been really, really bad. And we take on-site safety very, very seriously. So, we never cut a block and expose anyone to silica dust. So when a block goes into our saw, it's noise and dust suppressed, it's wet cut, and we capture all that material, and it goes back to a dump point, and that can go back to the brick factory and be used if required as what they call grog. That and other, any sort of broken bricks, other stuff that you crush up and you put it back in as aggregate. So just dust on a work site is one of the key components that we think we've addressed very well. But no one lifting heavy things, no one having to stand on drums and planks and scaffold and all this stuff. It's all gone. We don't need any of that now. You can do all that from ground level with a tablet in your hand and let the machine do all the dull, dirty and dangerous things.
Yeah, I think that's very enticing to a lot of people. And once you talk about it like that, it just seems so obvious
Doesn't
in
it?
kind of in hindsight.
Yeah.
Um,
I mean, we've
so
built houses, Jarrett, in the residential area in Western Australia, and we've built ours right next door, to homes that are being built manually. And some of the hazards that the contractors are having to work in amongst, really, it's quite poor. I mean, they don't have a choice. These people are doing the best they can, and they work in a damn hard industry. It's hard work. Construction is a hard industry, and the people that are out there, the guys and girls that are making a living in construction, they're earning every dollar that they make, I can tell you. So anything that comes into the industry that makes their job safer and easier, I think, will be adopted, very well and very quickly.
before you were CEO of FBR, what were you doing with your career?
I was in the aviation environment, so immediately before FBR, I was an airborne mission coordinator with Australian Search and Rescue.
Cool.
I flew with them for 10 years as a sensor specialist, radar, infrared, night vision type stuff, but also tactical and strategic flying and planning and going out and finding people that are in trouble and all that sort of thing. And prior to that, I flew for 10 years with Australian Border Protection, which is pretty much the same as your Coast Guard. So 20 years in the air for me, and another decade or so before that of ground-based aviation roles. And Mark, he did most of his aeronautical engineering training in the Air Force. He went in as a young man and came out with those sorts of skills. So we both have aviation backgrounds, but for me it was in the operational aviation background, and for Mark it was making the gadgets basically that I was using in the air. So there's certainly synergies there between the two of us.
Yeah, that's really cool. What kind of planes did they let you fly?
In Australia, we had some little three-seaters which we used for what we call littoral surveillance. So, we have a lot of coastline that's very remote in Australia, and it still needs to be patrolled, and it needs to be patrolled at very low level. So you do that at anywhere between 100 and 500 feet, and you're sort of flying down below treetop levels. You do a lot of that in three-seaters, but your sort of broader range surveillance is done using Dash 8s. With sort of long-range radars and long-range vision systems and covert capabilities. So it's quite a range of stuff that government agencies have at their disposal, and I was fortunate enough to be one of the people using that equipment for 20 years. Very good. I loved it. It was a fantastic environment.
What was the most unlikely rescue where you guys still made the recovery?
Oh, look, one thing about search and rescue, Jared, is that not every job you do is a success, unfortunately. The ones that really resonate with me are at both ends of the spectrum, where you sort of have a success that you weren't necessarily planning on, and some things just went your way on that particular job on that particular day, and other times when you think you're going out to a pretty standard routine type job where you might have a vessel that's in distress or something like that, and you get out there and there's it's a complete debacle and loss of life and all that sort of thing happening. So it can be a very difficult job in that regard, but at the same time very adrenalizing, and sort of getting a call at 1 o'clock in the morning and launching into the darkness 30 minutes later into a cyclone, for instance, or a hurricane. When everyone else is trying to get out, first responders are going in. And I think Americans appreciate first responders more than any other country in the world. You guys do it very well. I don't think necessarily in Australia our first responders get the recognition that they deserve. But literally many times, as I said, when everyone else is trying to get out, you're going in, and you go in regardless. So yeah, I loved that. It was a fantastic 20 years of my life. I loved it.
Yeah, it's an interesting long time spans, like basically a decade at a time. A decade in the first aviation role, a decade in the second aviation role, now almost a decade at FBR.
Yeah, I haven't had a lot of jobs in my life. I tend to stay in a job for, well, it seems to be on average about a decade in a particular role. And I think, people say that there's like a 7-year itch, where at the 7-year point, everyone sort of starts to reflect inwards and ask themselves the questions, am I making a positive impact? Is this still the right thing for me to do, or do I need to change? I don't think I ever really thought about things like that. I think these changes just came up for me, and I don't think I've actually ever even applied for a job, maybe only one. Most of the jobs that I've had in my life, I've got through word of mouth, because I've always worked hard, and I like to think that I give my employer, good bang for buck, and I'm hoping that my shareholders right now think that I'm giving them good bang for buck. We are working very hard as a team and as a company, and we've got 8 years of machine development behind us now, and a whole world of commercialisation in front of us. Now, this is the exciting bit. It's like doing all the hard groundwork to get to the point where you go and do the interesting stuff. Well, that's where FBR is right now, and of course, one of the most interesting environments in the world for construction automation is the United States. And it's coinciding with, labour constraint problems. The cost and availability of labour has never been more of a problem for the industry. We don't only have interest in what we do in Australia and the United States. Obviously, the Middle East is a very big market for us, as is Europe and the UK. And we've sort of approached the United States as our first overseas geographical opportunity and challenge, because it's coinciding with some very important things that are happening in your country at the moment, particularly in Florida, particularly with the cost of construction labour. And it has presented us with a very interesting opportunity and business case. And the industry participants there are very open at the moment to change and adopting new technology. It still has to be better, cheaper and faster. And this isn't the first show that I've used those three words on, Jared. I've spoken about those three things before. But you just have to be. And that has to be your goal if you're developing a new tech, or you're the CEO of a company that's trying to develop something for the industry. They've got to be the first three things that come into your mind every day.
I agree. That's the most important goal by far. I just can't wait for the day when somebody's able to come on the show and present line item data to demonstrate it sometime.
Well, I would like to be that first if I can, but as I said before,
I'm ready when you are.
Yeah, I'm sure. But I have to make sure that the market has that information before you get it. But ours is pretty simple to work out, I think, because if a machine costs X and it survives for X amount of years. Let's just say a machine costs $2 million and it can live for 12 years with upgrades and bits and pieces. And you're laying 300 $2 blocks an hour, so each cinder block's $2 US basically, a bit cheaper sometimes. And you're laying 300 an hour, and each house has around about 3,000 of them in there. You can sort of work out how fast you can lay 3,000 blocks, and you can work that out on what your machine cost is going to be per day, and you can come up with your own daily profit margin if you want. I just can't say it to you publicly, but they're not hard things to work out, okay? If I said to you, it sort of takes us anywhere between 1 and 4 days to set up, and it can take anywhere between 1 week and 3 weeks to build the structure, and it can take anywhere between 1 day and 4 days to remove all of our equipment, you'd have a very hard time pinning down a cost. But when a machine can arrive and within 1 hour start laying blocks at 300 blocks an hour and lay 3,000 in a day, potentially, and leave, you can work that out.
The only way I know how to work out the cost is if you separate it by subcontractor, and if you can break it down in between materials and labor, but that's an extra detail that's not really required. And then you can check the subcontractor tax records against what the GC reported and really figure out the details.
Yeah, I mean, we've got to be sure that we're being compared, apples for apples, as we say. I mean,
it's hard to do.
You could put 5 masons on a build, or you could put 50. You'll get a faster build with 50. You won't get, block per man speed increase, because the more people you put on a building site, generally the more chaos. And it's very hard to keep 50 block layers fed with blocks and mortar as they're building things. So it can become quite a chaotic work site. So you've got to make sure, what's a standard masonry team in the US? Is it 3 guys? Is it 5 guys? Is it 10 guys? How long does it take them? What do they charge the builder or the GC for that service? And then you'd compare us and say, well, what do you charge the GC for the same service? I can tell you now, it'll basically be dollar for dollar. It's just the profit margin in the middle will be different. We don't want the
That's a little hard to believe based on the pace of scaling, but I guess it'll become obvious in the next coming years if it becomes kind of ubiquitous, and time will certainly tell.
Yeah, it will. I mean, making lots of machines takes time. So, we're not about to, saturate the industry with a whole new method or way of building homes and commercial structures. But we're about to show the world what it's going to look like in the next 10 years and beyond. That's a given. And we're going to present that in a way that I think it's going to be very compelling for industry to adopt it. And that is because of the advantages that it's going to present. Just on the safety side, the work site safety side, if looking back a decade, just on the improvements that we make in work site safety, this was an endeavour worth taking on, just for that, let alone the fact that we're addressing the labour constraint problem and the cost and availability of that labour, and that we're presenting the brick and block manufacturing community with a way of ensuring that their product continues to be a ubiquitous building material into the future. Because for a brick and block manufacturing company, they rely on those manual masons to put their product up in the field. If they disappear completely, then bricks and blocks no longer need to be made. You'll have to look for other methods of building. So for brick and block manufacturers, I think it's really important. That's why I think they make ideal partners for us, expansion partners, because they bring so much to the table, and it's giving them an opportunity to ensure that they're locking in the future output of their very expensive infrastructure.
Yeah, it's obvious to me to be excited about the future of Fastbrick Robotics, because you guys have all the benefits of utilizing the digitalization you have now, and whenever new technology comes around, like that laser system, or maybe even like humanoid robots from Tesla or Atlas or one of these other companies, you'll be able to benefit from that way more than traditional construction companies, because you'll be able to feed those robots the data from your current robot, and the communication with people who already know how to integrate technology on the job site will be an exponential difference versus traditional contractors trying to implement any kind of technology for the first time.
You're right. And, we haven't really engaged or headed down that pathway yet. We know it's there as an opportunity, but we haven't exploited it in any way. We think that will happen naturally once we get our machines onto building sites and companies are using other people's technologies. And I think those things will naturally gravitate towards each other, and these obvious benefits will become very apparent very quickly. And then, the relationships and the commercial partnerships would naturally be formed from there. But, we know that there's some fantastic companies and technology in the United States at the moment, and we see the benefits that they bring. We see where we can, get involved in that at the right moment. It's not yet, but it's very fast approaching.
If someone doesn't have their own design in mind yet, you mentioned you created a software for people to create models.
Yeah, simply we've got our own bespoke software that we've developed in-house over the last 7 or 8 years, actually. We've always had a software team working in conjunction with our machine development team, because the two things have to be done in parallel. It's one thing to have a machine that can build a house, but if it takes a week to get the data that you need to create the build program for the machine, well, guess what? You're not in the game. So your software system has to be able to take a builder's design and very quickly turn it into a program that the robot can build to. Now, our system, our software program, we've called TAD, T-A-D, and it stands for the Architectural Designer. Not a great name potentially, maybe, but that was something that I came up with a long time ago, and it's sort of stuck because it's sort of TAD, CAD, and all those sorts of acronyms. Yeah. But we simply can take your Revit or your ArchiCAD design, click and drag it into our software, and very quickly it will give you a whole range of interesting information while it's generating a build program for the machine. So, for instance, it has a library, a brick library. So you can choose an Australian CMU block, you can choose a USA cinder block, a German clay block, a Czechoslovakian AAC block. They're all in the library. We all know their exact dimensions. If you click on one of those particular block types, it will populate the structure with that. It will tell you exactly how many you need to order. It will tell you how many need to be cut, and it will give you an exact amount of waste that you're going to produce using that block in that design. And we did that early because one of the things we wanted to capture here was reducing the amount of masonry waste that goes into landfill, because it's just not acceptable what's happening around the world at the moment. Now, that feedback loop for the builder and the designer and the architect is very important from our perspective, and we think that they will use that very, very well. But we wanted to ensure they had full visibility on what they were proposing to build, the product that they were proposing to use, and the amount of environmental impact that was going to have. So we've captured that in our software, but for the whole process is inside an hour. Now, we've also designed it to be a web-based portal. So we want the builders and the architects to be able to use it themselves, come up with their own sort of solutions or data set, make their own decisions on the block type, and if they want to move a window or a door a little to reduce the amount of cuts and reduce the amount of waste, they can do that themselves. Or if not, they just say, it is what it is. We build 1,000 of them a year. So there's the design. Convert it. Once you've converted it once, you don't convert every house. It's just every design. So some of your high volume builders in America, for instance, will build anywhere up to 2,000 to 3,000 of the one design every year. You only got to do that once, one hour process, and that design's done. And then you just email that program to the machine en route to the job site if you want. And then when it gets there, take your survey points on your slab, load the bricks in the back, and start building. It all happens very quickly.
So when you say 1 hour process, are there any humans in that loop, or is it just a 1 hour compute?
It's a 1 hour compute. Now we have a team of only 3 or 4 actually in our software team at FBR, and we've got a number of sort of milestones that we are looking to hit this year to make that a complete external process for the builders. At the moment, you might get a call come in from builders and say, look, I'm just converting this design. Is this correct? Have I done that right? It's like, yep, you have. That's all good. Or no, let me help you with that. And, but over time, it's like any software product when you first introduce it to the market. You have those little sort of quirky things going on. But we do have builders now that do it completely themselves. There's no interaction with us. So they have adopted it well and they're using it well. So that works.
Yeah, that's very cool. So what else didn't we cover?
I don't know. I think we might have got the lot there. If I was starting this journey all over again, I've heard this from some people recently. They've said to me, oh, you guys have done it all wrong being a public company. I would never have done it like that. And in hindsight, probably nor would I. But we had very limited options. We knew we had something we wanted to develop, and we knew something that was going to take a number of years and quite a lot of money to get there, and it has. But we knew that the prize for the hard work was going to continue to get greater every single day on the journey, and it has. And we think we're at the point in time now where we're ready to, we're still early, but I've said this a number of times, even to my own team. In technology, you can be early, but you can't be late. And we'll be presenting our tech probably a little bit earlier than I would like, because, everybody wants to be everything to be perfect all the time. We do. I do. It's just the way I approach things. But you don't always get that. So sometimes you've got to take your product out to market the way it is, and then it will continue to develop and improve over time. And I think our continuous improvement program will exist long after I'm gone. These machines should continue to get faster and better. The wall quality should continue to get better all the time. I think the adoption is going to continue to increase over time. I can see tens of thousands of these machines required around the world. We know what we can see in the United States right now, and it's a lot. Similarly in Australia and in Europe and the Middle East. And if you sort of work out a plan where you can try and make a couple of hundred machines a year with a solid partner, then the opportunity's there to be grabbed, and we think we've got everything sort of well lined up. We have a good OEM relationship with Liebherr now. We have had for a couple of years. They've assisted us in some of the design of the machine in the early days when we were sort of at the design table with the commercial machine, because we wanted to make sure that it was manufacturable as a machine, that it can be manufactured in sort of components and then assembled in a way that an OEM would like it to be done.
Robust, weatherproof.
Yeah. So we've done all the things that we need to do in the early days, and now as we align properly with our OEM partner in the months and years ahead, you start off producing 10, and then you do 20, and then you do 40, and then next thing you know you're doing 100 a year, and then that can go to 200 a year, and I can see 5 years from now 100 machines a year coming off a production line. That should be what we're targeting, and if we're doing that, and each machine's potentially generating $1 million of free cash flow a year, they're good numbers, and I think our company will be valued very well for it.
Entering a chapter of what Elon Musk would call manufacturing hell.
Precisely, yeah. And, obviously everybody, I think, in the technology development world follows what's going on there and has, followed that journey as well. Trying to learn lessons, I think, that you don't have to do yourself or must find mistakes that you don't have to replicate yourself. But for the most part, I think, and anyone would tell you this, that's in a similar position to me, is that, you just got to get your scars and you got to make your mistakes. And, technology developers are solution providers. We're trying to solve problems. All right, that's what we do. We solve problems. And for us, we're the only people in the world trying to solve this particular problem of building better, cheaper and faster with construction robots that use bricks and blocks out of a brick plant. Okay? We are the only people doing that. So we can't sort of look over the fence and say, well, what did they do to solve that problem? We have to
There's
solve
quite a different product called the Bricklayer 3000 that does it just a tiny little brick walls at a time, but quite different from your system.
Yeah, we see all those things, and there's about 400 patents filed every year in this space, a lot out of China. We've been one of the highest filers of patents in Australia for a number of years now. We have, I think, around about 30 patent families and over 250 patents in various stages of either granted or in process. We have a very comprehensive IP strategy to ensure that our IP is protected for today and into the future. And just recently, we made a public announcement about the new filings that we've made around the new machine. So we think we've increased our barriers to competition by at least another 15 years. So it gives you, you've got to sort of buy that time. If you're spending money on solving problems, you have to be able to recoup that and to make sure that no one else can come in and sort of take that or pull that rug out from underneath you. You have to continually protect what you find and develop and create. And I think FBR has done that very well. And we haven't seen the value of that yet. The value accretion into the company based on our IP has not happened yet. But we can see a point in time where that will become more apparent, and the value of FBR will be based, significantly on that IP suite that we have. But for every tech developer, I think at the end of the journey, you're just a scarred mess and a shadow of your former self, and if you can come out the other side, with a smile on your face, and still feeling positive about the decade of your life that you've spent trying to solve these problems, then it hasn't been a waste of time, right?
Beautifully said. Murphy's Law, anything that can go wrong will go wrong. Enough of those things happen, and some people give up on the path, but the people who keep going are the winners in the end of the day.
End of the day, I think so.
So you brought up something I wanted to touch on a little bit more, your partnership with the OEM. Partnerships, they say, are so key to construction and innovation in construction. Is that your primary partnership? Do you have other key partnerships?
We do have some key partnerships, but not contractual partnerships. We have some key relationships with certain industry participants, whether it be on the brick and block manufacturing front, or whether it be on the machine front or the laser technology front and those sorts of things. Because stuff's being developed and improved all the time, and you've got to make sure that you're at the table when those discussions are being had and those new products are being presented. So yes, we have an important network of people and companies that we deal with. But with regard to the OEM, with Liebherr, I mean, we have an exclusivity period with them, which we're likely to extend because we have a very good relationship with them, and we've always believed that they are the best fit as a manufacturer of a machine like this. And similarly, they don't see any great challenges in manufacturing Hadrian machines either. I mean, that's all yet to be properly found out, I guess, when we get into it. But Yeah, they've been fantastic to work with, and the relationship that we have there, a non-contractual relationship, if you like, is really strong. And I think it's important that relationships are built on that too. They're not just like, okay, we've got two pieces of paper, you've got to do this and I've got to do that. There has to be this thing in the middle, this cooperative atmosphere in the middle, or things just simply don't work. And I think we're a pretty easy group and team and company to work with. I hope others would say the same. But we're not out there trying to create problems or anything for anybody. We're trying to solve them, and we look to our partners and collaborators as people that can help us solve those problems, not create new ones. So it's a very important part of any machine development, regardless of what it is, whether it's a handheld gadget or something that you drive to a building site, Jarrett. It's a very important component for sure.
Yeah, it's great to hear all these insights, and I hope that we were able to demystify some of the excitement around bricklaying robots and how the process maybe isn't so different than people expect from traditional construction. Besides, I guess, the adhesive in the mortar.
Yeah, look, you can't think of a haging machine and go, oh, there's a problem for the builder, that thing's going to site. It has to be, oh, that house is going to be built better, cheaper and faster. Okay? And I'll keep banging on about that because I see so much money being expended around the world on different, methods of improving construction outcomes. And they are not part of the conversation, those three things, and they need to be. And
I hear you need about a 25% cost benefit to get everybody to switch over, no questions asked, because of the challenges of learning new things. And that's, of course, like you mentioned, not just the total financial dollar amount, but the amount of time they can collect rent on the building, interest on the construction, all those things.
Cash flow improvement is a big one for builders. If you're building 100 homes a year, one of your biggest inhibitors to producing 200 homes a year is cash flow. Now, if you can free that up by speeding things up, it assists those builders that are building at that level to take that next risky step up. Every time a builder takes that next expansion step, they're taking on risk. And it's up to us, technology developers to give them ways of expanding and improving their output without taking on unnecessary risk. The world needs more homes. There are 3 billion people coming to this world in the next 30 years. We've never seen anything like this. The solution to putting roofs over all those people's heads has not been found yet. Okay? 3 billion more people need to be fed, watered and housed in our lifetime, your lifetime, and maybe hopefully even mine. Now there's the challenge, okay? Come up with a way of helping that problem. We think we've got one. We think the 3D concrete printing community have got one as well. We think there's certainly scope for that to assist with that very big problem. But it opens the door for a whole range of new materials, new building methods, new design concepts. It all has to come out, and quickly. We don't have time. We're not going to say, hang on with that next billion people. We haven't quite finished housing the last billion. They're going to just keep coming. And we cannot continue on down this homelessness cycle that it seems like every country in the world has just accepted as normal. I can't ever accept that. I won't ever accept homelessness as normal. I think it's up to tech developers to give builders solutions to problems, give them the ability to increase their output without increasing their risk, and give them a reason and an ability, and give governments a reason and an ability to start getting in behind this problem. Because you increase the world population by another third, and maybe you've increased the world's housing number by 10% of that. I mean, there's a big problem coming down the tube here. And, that should be in the forefront of everyone's mind right now. It is in mine.
Yeah, mine too. I think construction automation is super important to me, and I think the audience as well acknowledges the importance of the problems that you brought up. So I think that will have resonated strongly with them. The thing I keep wondering is, of those 100 systems you're going to be manufacturing a year in the future, will they be operated by Fastbrick Robotics or independent contractors? But I imagine that's in the realm of things you're not ready to talk about yet.
Oh, look, I think, you can naturally see that in the early days, and it's happened in the past, you can look historically, this is how things generally go, but in the early days, you keep your hands very close to your equipment. But what we have and the model that we want to take to market lends itself very well to the franchise model, where, someone might say, well, instead of me buying, 5 excavators and 5, bobcats or front-end loaders, and I'll go into the earth moving business, someone might say, I'm going to buy 5 Hadrians and I'm going to go into the block laying business. Now that makes perfect sense. And the way that we are, I suppose, establishing the wall of the service entities in the early days will lend itself reasonably quickly to transitioning over to a standard franchise model. And that's what we would ideally like. And that's
Very
certainly
cool.
what an OEM would like to see too, is that you've got multiple orders coming in from multiple companies who want to buy 5 or 10 machines and set themselves up as a contract bricklayer using Hadrian machines as opposed to using humans. That will happen in the next 5 years, in my view. So there's no secret about that, Jared.
Yeah, cool. That's a cool insight. And is there any anticipation of what your training systems will evolve to at that point?
Yeah, they need to get better, as with everything. I've been fortunate over the journey to have spent time with a number of OEMs around the world, and most of them have very good simulators setups now for all of their equipment. If you want to buy a Caterpillar D9 bulldozer, well, you can send your operators to one of their training centres, and within a few days they're fully swept up on how to operate that machine. Similarly, we'll develop simulators for the Hadrian machines, and we'll do that, I think, in conjunction with our OEM partner, because they're well experienced and well versed in that arena. But if you think about the fact that the Hadrian machines can work 7 days a week, 24 hours a day in almost any weather conditions, probably barring some of the wet season conditions we're going to get in Florida next year, because I know what torrential tropical rain looks like, because I live in the tropics in Australia. If you've got 5 machines and you want to run them 7 days a week, 24 hours a day, and the only limitation to that at the moment is regulation, because a lot of places in the world have this Monday to Saturday, 7 a.m. to 7 p.m. Work window. It is in Australia and it is in the United States in most areas. But there are places in the world where they don't, where you can just work a machine 24 hours a day, 7 days a week. Now, if you're going to do that in that area, let's just say you want to introduce 10 machines into the UAE where you can work 24 hours a day, you basically need 6 crews per machine. So you need 18 people. You need 180 people trained across 3 different disciplines. And I think that there's a very good opportunity for training providers to potentially take this role on and say, well, we'd like the job of training Hadrian operators in the future, and we'll charge X. And maybe we on-charge that to the people who are purchasing the machines. And then, every new batch of people that need to be trained go through that training regime at a particular cost to the machine owners. And then, at some point in time, it's probably going to be an online training program where they log on at 7 o'clock in the morning and log off at 3 in the afternoon, and they're basically using their simulator at home. These things are all going to happen. But the training thing for me has always been an important one, because I was a trainer in the aviation environment. I trained aircrew, and a lot of them over the years. And I know what resonates well with people when they're learning something for the first time. And it's got to be interesting for starters. What you're learning has to be interesting. And if you've got something that's constructed well as a training program, and the content's interesting, it's really easy to keep your trainees engaged, and your outcomes are always much better. And I think construction robots are pretty cool. Even as an old bloke, I think they're pretty cool. And I think training young people, girls and guys, okay, so this is now, we've got a diversity thing going on here too. Now, there's no reason why women can't drive these robots just as well as men. No one's lifting heavy things, or there's no limitation or difference between a man operator or a woman operator. So it expands the capability of companies to employ completely, gender free, or whatever you like to term that.
Some people say there are some statistical spatial recognition differences, but who knows?
I'm not going down that path. I'll leave that to you. You can take all the negative comments about that. Um, but we have had some female operators in the past as well, and they work just as well as the men with technology and training people for me and providing good training courses for me is an important part of what we're doing. We haven't had to focus on that a lot. But over the last 6 or 12 months, it is certainly becoming, a rather larger phase of our business and our approach.
Yeah, for sure. It's interesting. I think that the factor you mentioned, like the passion people have for it, and working with robots, it gets young people excited in those kind of jobs and stuff. Um, that's a big reason I started the Human Robot Army, a recruiting firm for people who want to work with robots in construction, because my audience is so passionate about it that they have that extra kind of grit to get through the tough days when things aren't as easy as they anticipated, but they're
Yes,
doing what they want to be doing, and so that passion gives them the extra motivation. I guess like in aviation, the people who
100%.
spent their whole life excited about planes
Yes,
maybe become the best pilots.
you got it, mate. 100%.
Cool. It's good to hear that, and it's exciting. Maybe somebody's listening who has some kind of AI headset that can build some kind of simulated training model for your future team members. That'd be pretty
We've
cool.
looked at some of those. I mean, there are some great products already out there on the market. We see them, and we think that our operators in the future will wear a headset with a heads-up display and getting an augmented reality type view of what they're building in front of them. That's there now. I just don't think the industry's ready to see people that look like Martians walking around on a building site. So we'll go there in steps, but we could go there today. But I think that's potentially a bridge too far for a lot of builders. They don't want to see that type of change that quickly. Going from a team of humans to a machine, yeah, okay, that's doable. Show me, prove it to me, and maybe I'll accept it and adopt it. If I said, look, I'm going to bring a robot to your site and I'm going to have 3 guys walking around looking like Martians for a couple of days, you're probably going to have to keep the people walking down the street, away from the site because everyone's going to be taking photos of all this weird stuff going on. That's probably a bridge too far at the moment. But, within 2 or 3 years, that is not an unrealistic thing to sort of get your head around. I think that will naturally happen.
Well, it's really exciting stuff, and I can only imagine there's going to be so much more wind in your sails as technology continues to kind of like level up different aspects of the system, and the whole process, like you said, every part is always improving. So good
Yes, it
things in the
is.
future coming.
Yeah, you've just got to have the tenacity, and as you say, keep the wind in your sails moving in the right direction, and keep your nose pointed in the right direction. And if you can live the journey long enough, you'll eventually get there. And for us, we're stayers, so we're not going anywhere, and we've spent too much time and too much of other people's money getting to this point for us to slow down now. This is the exciting part of the journey in front of us now.
As our call comes to an end, do you have any call to action for the audience? Should they check out your website?
Yeah, look, we do have some great content online, www.fbr.com.au. Most of our content we create internally ourselves. There's a whole range. I think everything we've built, or most things that we've built, we've created a video or a movie of
Nice.
or on. So yeah, please get on and have a look at it and make up your mind for yourself. Compare us to what's happening at the moment around you. If you're a builder, or if you're a mum and dad investor and you like technology, we're a listed company. Anyone can invest in us.
Awesome, Mike. Thank you so much for joining me. I really appreciate the time you took to illuminate Fastbrick Robotics.
Thanks, Jarrett. It's been great being with you.
Yeah, hopefully we could do this again.
Okay.